Alright, welcome back. This is another installment in our video series on really developing some fundamental skills to really attack algebra full force. So in this video we're going to talk about something very simple in the sense of combining like terms, but there's going to be some nuances to this work that we'll explain here in a second. So when we're talking about like terms, we're really thinking about terms that contain the same variable part. And we want to be very specific when we're talking about variable part, because what we're really looking for are terms that have the same variable with the same power. Because we could have something like 2x squared plus 3x plus 5x to the fifth. And these all have the same variable part, but they don't have the same power, so we wouldn't consider these like terms. Now, like terms have identical variables and identical exponents. That's going to be the primary key takeaway here. So if we're looking for like terms, we're looking for terms that have the same variable part and the same exponent. So here we have four different terms. This term has an x variable, this term has a y, this term has a y, and this is a constant term. So these two terms right here are going to be the only terms that we would consider like terms. Okay. Now we want to combine the like terms. We're either going to add or subtract the like terms. And what we're going to do is we're going to focus on the coefficients here. That is the number that goes in front of the variable. So the 20x is going to stay the same, but then we're going to have 5y plus 2y. So what we're going to do is take the 5 plus 2 gives us 7y, and then plus negative 3. Or we could write this as 20x plus 7y minus 3. Both of these would be equivalent. So again, just to recap, when we're combining like terms, all we do is we add or subtract the numerical coefficients. That is the number that goes in front of the variable. So here in example A, we're going to look to examine the variable part to make sure that they're the same, and they are. So we're going to have negative 4 plus 8, which is going to give us 4, and then remember to keep the variable the same. Now in part B, we have three terms, 5x plus 3x plus 2x. All three of those variables are the same, so it's going to be 5 plus 3 plus 2, all times x, which is going to be 10x. So again, once you identify that the terms have the same variable, all you need to do is add the numerical coefficient. So here we're going to have 5a squared minus 2a squared plus 6a squared, so they all have the same variable part. So we could write it like this if we really wanted to. Okay. Now 5 minus 2 is 3, 3 plus 6 is 9, so this is going to result in 9a to the second power. Here we have a little bit of a different scenario because we have an a here, and then we have a, or b, oh, I overlooked that one. Scratch that. We have a b cubed, and then we have an a cubed. So what we could do is we could combine the terms that have the same variable. So it's 12 minus 3 times a cubed plus 5b cubed, because there's no other b cubes, plus 1 plus 8 times a. You'll notice that this has an a just by itself, which tells us that there's an invisible coefficient of 1 there. So now that we've set up all our like terms, we've got 12 minus 3, which is going to result in 9a to the third power, plus 5b to the third power, plus 9a. And just be careful not to try to add these together to make them 18a to the fourth or something like that. We can't combine those because they don't have the same variable with the same exponent. Now this is going to get a little bit dicier because we're dealing with fractions. So the only way we can combine fractions is to make it so the denominators are the same. So here we have 2/5 c minus 3/4 d squared minus 1/3 c plus 7/8 d squared. So these two are going to be like terms, and then these two are going to be like terms. Now we look at 5 and 3. They're relatively prime, so our least common denominator is going to be 5 times 3, or 15. So I'm going to have to multiply this by 3 over 3, which gives us 6 over 15. And then this we're going to multiply by 5 over 5. So it's minus 5 over 15. And I'm following the same sort of methodology as before. I'm including the coefficients inside the parentheses, and then I'll simplify those. 1 over 15 times c. And then we're going to have plus, we've got negative 3/4 d squared plus 7/8 d squared. So the LCD of 4 and 8 is 8. So I'm going to need to multiply this by 2 over 2. So it gives us negative 6 over 8 plus 7 over 8. And remember, d squared is the variable for that particular situation. Negative 6 plus 7 is 1. So it's going to be 1/8 times d squared. So this problem is a little bit more complex just because of the sheer fact that it included fractions. So just remember, once you identify the like terms, you're going to need to manipulate each of the numerical coefficients to make sure that they have the same denominator, so we can either add or subtract those fractions relatively seamlessly. Now here we're going to apply the distributive property before we combine like terms. So we're going to take this 8 and we're going to multiply it by 3x, which gives us 24x minus 8 times 2y is 16y plus 4 times 3 is 12y, and then 4 times negative 5x is going to be minus 20x. So we have 24x minus 20x, so we can take our coefficients, take 24 minus 20, multiply that by x, and then we're going to take plus, we're going to take negative 16 plus 12, multiply that by y. So this is going to give us 4x plus a negative 4y, or 4x minus 4y. Make sure I distributed that correctly, and I'm going to hold back a sneeze here, and I think we're in pretty good shape. Okay, that's it. Hopefully this video was informative and helpful. If you need to go back and watch it again, make sure to pause it, write down the examples, and walk through it step by step as I show you the example. If you have additional questions or need to ask a follow-up question, definitely reach out to me and let me know, and I'll do whatever I can to provide the necessary clarification. Thanks again for hanging out. I look forward to seeing you in the next video.